Today we will discuss network analysis. A network is a symbolic representation of the essential characteristics of a project. PERT and CPM are the two most widely applied techniques. First of all, we discuss about critical path methods. It uses activity-oriented network which consists of a number of well-recognized jobs, tasks or activities. Each activity is represented by arrow and the activities are joined together by events. CPM is generally used for simple, repetitive types of projects for which the activity times and costs are certainly and precisely known. Projects like construction of a bridge, road building, yearly closing of accounts for a company can be handled by CPM. Thus, it is deterministic rather than probabilistic model. Second, we are going to discuss the program evaluation and review technique, that is also known as PERT. It uses event-oriented network in which successive events are joined by arrows. It is preferred for projects that are non-repetitive and in which time for various activities cannot be precisely predetermined. There is no past experience to guide the ones through projects. Launching a new product in the market by a company, research and development projects of a war weapon, launching a satellite are per projects. Three time estimates: optimistic time estimate, pessimistic time estimate, and most likely time estimates are associated with each and every activity to take into account the uncertainty in their times. Generally, the projects which comprise of the variable type activities associated with the probability time estimates employ PERT version of the networks, and the projects comprising of deterministic type of activities are handled by CPM version of the networks. This is the main difference between the two techniques. The other difference between the two is that PERT is event oriented while the CPM is activity oriented. Now we will discuss critical path analysis. The critical path of a network gives the shortest time in which the whole project can be completed. It is a chain of activities with the longest time durations. These activities are called critical activities. They are critical in the sense that delay in any one of them results in the delay of the completion of the project. There may be more than one critical path in a network, and it is possible for the critical paths to run through a dummy. The critical path analysis consists of the following steps. 1. Calculate the time schedule for each activity. It involves the determination of the time by which an activity must begin and the time before which it must be completed. The time schedule data for each activity includes the calculation of the earliest start time, the earliest finish time, the latest start time, the latest finish times, and the float. 2. Calculate the time schedule for the completion of the entire project. It involves the calculation of project completion time and the probability of completion of the project or on or before the time. 3. Identify the critical activities and find the critical paths. Critical activities are those which must be started and completed on schedule, or else the project may get delayed. The path containing these activities is the critical path and is the longest path in terms of the duration. Now we are going to discuss terms related to events. First of all, we discuss about earliest event time. The earliest occurrence time or earliest event time is the earliest at which an event can occur. It is denoted by E2 for the event 2. Now second is latest event time. The latest allowable occurrence time or the latest event time is the latest time by which an event must occur to keep the project on schedule. Latest occurrence of an event is denoted by L, or it is for the activity or the event 2, it is denoted by L2. Now we are going to discuss terms related to activity. First of all, we discuss about earliest start time or EST. The earliest start time of an activity is the earliest time by which it can commence. This is naturally equal to earliest event time associated with the tail event of the activity. For example, EST of the activity 223 is the tail event is 2, that is E2. Second, we discuss about earliest finish time or EFT. If the activity proceeds at its early time and takes estimated duration for completion, then it will have an early finish. So earliest finish time of an activity is defined as the earliest time by which it can be finished. Now we discuss about EFT, earliest finish time. It can be calculated easily by EFT is equal to EST plus activity duration. Now we will discuss latest finish time or LFT. The latest finish time of an activity is the latest time by which an activity can be finished without delaying the completion of the project. LFT of the activity 2 to 3, we take the head, that is 3, that is the L3. The last is latest start time, that is LST. Latest start time of an activity is the latest time by which an activity can be started without delaying the completion of the project. Now LST can be calculated LFT minus activity duration. Now we are going to discuss what is slack. Slack is the time associated with the events. Slack of an event is the difference between the earliest event time and the latest event time. For example, slack of an event 2 is L2 minus E2. Now we are going to discuss an important term, float. Float is the term associated with the activity times. Float denotes the range within which activity starts time or its finish time may fluctuate without affecting the completion of the project. Floats are of the following types. First of all, we will discuss about total float. Total float is the time spent by which the starting or finishing of an activity can be delayed without delaying the completion of the project. Total float can be calculated by LFT minus EFT, or another formula is LST minus EST. Now we are going to discuss what is free float. Free float is the positive total float that can be used by an activity without delaying any succeeding activity. Free float is equal to EST of successor minus EFT of present activity. For example, free float of an activity 2 to 3 and with the time duration 6 is E3, head E3, E3 minus E2 minus 6. Then independent float. Independent float is defined as the excess of minimum available time over the required activity duration. For example, independent float of an activity 2 to 3 and time duration 6 is independent float of 2 to 3 is equal to E3 minus L2 minus 6. For example, we are going to discuss a problem. Task A, B, C, etc. up to H, I constitute a project. The precedence relations are given below. A less than D, that means D should be completed. The first A less than D means A should be completed first. After that, D can start. A less than B means A should be completed first. After that, E can start. B less than F, B should be completed first. After that, F can start. In the same way, you can do all the activities. Draw a network to represent the project and minimum time of completion of the project when time in days of each task is as follows. Also identify the critical path. First of all, we have to draw the task. Time is given also. So 1 to 2, we put the activity A, and 1 to 4, we put the activity as B, and 1 to 3, activity as C, and 2 to 6, activity E, 4 to 5, activity F, 5 to 6, activity I, and 3 to 6, activity H. Then we are going to find out earliest event time. The first of all, the time is event time. Starting event is always 0. We take E1 is equal to 0. Then E2, you can see that after E1 plus time duration, the time duration is given. E2 is equal to E1 plus 8, that is equal to 0 plus H is equal to H. Now that is E3 is equal to after completion of E1 plus the time duration, that is equal to H, E1 plus H is equal to H. Then you can see that E4. So if you want to start 4, it can come in both ways. That is, after completing the activity 2 to 4 and to 1 to 4, you can start only the activity 4. So there are two paths. In this case, we take maximum of E1 plus 10 and E2 plus 10. That is maximum 0 plus 10, 8 plus 10. The maximum is 18. Also, E5 also you can see that there are two activities are coming. After completion of two activities, you have to start activity I. So there are two branches. So we have to take maximum of E4 plus the activity duration and E3 plus activity duration. That is the maximum of E4 plus 17 and E3 plus 18. We get maximum value is 35. E6 is so you can see that there are three activities before completing the final activity. So it should be completed 2 to 6 and 5 to 6 and 3 to 6. So we take maximum of E2 plus time duration and E5 plus time duration and E3 plus time duration. So the maximum value is 44. We take E6, that is the last event. E6 is equal to 44. Then we are going to calculate L6, latest event time. That is, we start from the last event, that is L6. L6 and E6 are same, which is that is L6 is equal to E6 is equal to 44. Then just below L5, L5 is equal to L6 minus, not adding, subtracting L6 minus the activity duration. So we get 16 minus 9. L4 is equal to L5 minus 17. Then you can see L3. So L3, there are two joining junctions are here. So L3 is equal to minimum of L6 minus 3 and L5 minus L6 minus time duration and L5 minus time duration. Also, you can see that in L1 also minimum of L3 minus time duration, L4 minus time duration and L2 minus time duration. So you can see that the minimum value is 0. So you can see that L1 and E1 are always 0 and L6 and E6 are the same values. So we draw a table consists of activity, duration, EST, EFT, LST and LFT and float. So first of all, how to find out EST? So you can see that in the activity 1 to 2, EST is equal to the tail event of the activity, that is E1. That's in E1 is 0 here. We already found that E1 is equal to 0. Then how to find out EFT from EST? That is even so EFT is equal to earliest finish time, that is 0 plus this activity duration at 0 plus 8 is equal to h. Then before finding LST, you have to find out LFT. That is easiest way. LFT of the activity 1 to 2, we take the head of the L, that is L2. L2 is equal to h. Then how to find out LST from LFT? That is equal to LST is equal to 8 minus the time duration h, that is 8 minus 8 is equal to 0. Similarly for 1 to 3, EST is E1 and LFT is equal to L3 and EFT is equal to E1 plus the time duration h. Similarly, you can find out all the values of up to E5 and L6, that is the E5 is equal to 35, then E5 plus time duration 44, then LFT is equal to L6, that is equal to 44. 44 minus LST, the time duration, we get 35. So now we are going to find out the float. Float can be found by two methods, LFT minus EFT or LST minus EST. So 8 minus 8 is equal to 0 or 0 and 0. Then here 17 minus 8 is equal to 9 or 9 minus 0 is equal to 9. So you can see that 18 minus 10 is equal to 8 and 8 minus 0 is equal to h. So in this you can see that 1 to 2 the float is 0. There is no time gap between the, even so float is 0, and 2 to 4 0, 2 to 4 0, and again 4 to 5 is equal to 0 and 5 to 6 is equal to 0. So the float to 0 activities are known as critical activities, and the path consisting of the critical activities are known as critical paths. So here the critical path is 1 to 2 the float is 0, 2 to 4 the float is 0, 4 to 5 the float is 0, and 5 to 6 the float is 0. The path is known as this path, that is 1 to 2, 2 to 4, 4 to 5, 5 to 6. You can represent the figure by a double line. This path is known as critical path. The delay in the critical path will delay the project. Example 2. Also, we can find out the project duration. We have to add the project durations in 1 to 2, 2 to 4, and 4 to 5, and 5 to 6. We get the total project duration. The second example, we can see that construct a network diagram and compute critical path and duration, free float and independent float. Activities and durations are given. As before, you have to draw the network first. You can see the network 1 to 2, 1 to 2, 3, etc. You can see that. And also you have to find out E1, E2, etc. up to E1, E2, etc. up to E9. And also you have to find out L1, L2, L3, etc. up to L9. Okay, you can see that. Then also the table, you have to create table consists of activity, time, EST, EFT, LST, and LFT. And also you can find out the plot. You can see that LST minus EST or LFT minus EFT will get the plot. Here the plot, the critical activities are 1 to 3, 1 to 3 to 6, and 6 to 9 are the critical activities. Okay, 1 to 3, 3 to 6, and 6 to 9 are the critical activities. The path is known as critical path 1 to 3, 3 to 6, 6 to 9. The two duration 2 plus 8 plus 5 that is equal to 15 months is the project duration. Now we are going to find out the free float of an activity. Already we discussed free float at activity 2 to 3 is equal to E3 minus E2 minus project duration that is equal to 1. And also independent float of an activity 2 to 3 is E3 minus L2 minus activity duration. In the following table, you can find out all the independent float and the free floats. Now we are going to discuss program evaluation and review technique. The main difference from the examination point of view, if time is given, time duration is given, that is a CPM network we can use. The time estimate is not given. We are using program evaluation and review technique. The CPM system of networks omits the probabilistic consideration and is based on a single time estimated the average time required to execute the activity. The persistent is based on three time estimates of the performance of time of an activity. They are the optimistic time estimate, that is T0, or the small letter a is used. The shortest time required for the completion of an activity if all goes extremely well. No provisions for delays or setbacks while estimating this time. That is optimistic time estimate T0 or small letter a. Second is the pessimistic time estimate TP, or the letter B is used. The maximum possible time the activity will take if everything goes bad. And the last is the most likely time estimate, that is TM or M. The time of an activity will take if executed under normal conditions. Actually, it is the model value. For determining the single time estimates used in CPM, some historical data may be available, but the best way of predicting the three estimates is by intelligent guessing. The expected time or average time of an activity is equal to the time that the activity is expected to assume while executed. That is TE is equal to the estimated time is T0 plus 4Tm plus TP all divided by 6. And variance is equal to TP minus T0 by 6 the whole squared. Okay, after finding the time estimates, you have to, after drawing the network, you have to fill up the activity duration time by this T. For example, the time estimates in weeks for the activities of per diagram are given below. Activity is given, T0 is given, TM is given, TP is given. Optimistic or A or M or B. Here, time duration is not given. We are going to estimate time duration, that is TE is equal to T0 plus 4Tm plus TP by all divided by 6. Then what are the question? Draw the project network and identify all the paths through it. Determine the expected project length. Calculate the standard deviation and variance of the project length. What is the probability that project will be completed at least 4 weeks earlier than expected time? No more than 3 weeks later than expected time. 5. If the project 2 is 19 weeks, what is the probability that of not meeting the due date? The probability that the project will be completed on schedule. The scheduled completion time is 20 weeks. So you have to find out the estimation, that is time is given. So draw the network. As before, you have to find out EST, EFT, LST and LFT, and E1, 0, E2, E3, etc., L1, L2, L3, etc. Then plot you can find. After finding the 0 critical path, you can see that expected project length is equal to 17 weeks and variance is equal to 9. Then probability that the project will be completed at least 4 weeks earlier than expected, because we found out that expected project is equal to 17 weeks. Earlier than 4 weeks, that is the work should be completed 17 minus 14, 4, that is equal to 13 days. That is probability of x less than 30. You have to find out. It follows the normal distribution. So we convert into standard normal distribution for finding the probability. Then let z is equal to x minus the expected value, that is equal to 17, minus the standard deviation, that is equal to, here we found that the variance is equal to 9, that is square root of 9, that is equal to 3. So probability of x minus 17 by 3, and the same operation here, 13 minus 17 by 3 is, you can replace x minus 17 by 3 is equal to z, that is probability of z less than minus 4 by 3. So probability of z less than minus 1.33. It is coming in the left hand side. So you know that minus infinity 0, the probability is 0.5, and instead of finding probability of minus 1.33 less than z less than 0, you have to find out probability of 0 less than z less than 1.33, because the symmetric property of the standard normal distribution. This value is found out the table, that is answer 0.4082. Subtracting we get 0.90918. If we are multiplying with the 100, we get 9.18%. The meaning is that if the project is performed 100 times under the same condition, then there will be 9 occasions for this job to be completed in 4 weeks earlier than expected. Second question, the probability of completing the project not more than 4 weeks later than expected is given by, because we have to add 4, that is 17 plus 4, that is equal to 21. That is, you have to find out probability of the work should be completed less than 21 days. That is probability of x less than 21. As before, let z is equal to x minus 17 by 3. The same operation here, we get probability of z less than 4 by 3, probability of z less than 1.33. That is,